Tell me what is the difference between heat and temperature? 它们的分别是什么 ？Anything that you can think of, just try it out. Doesn't matter if it's wrong or right. What is the difference between heat and temperature? Are they the same? Or is it different? Right. Temperature. Heat. Again. Temperature. You are asked to define. Yes, sir. You will be asked to define. Meaning that you will be asked to give the meaning. What is the heat? What is temperature? In SPM, yes, it's one of the syllabus. Heat is quantity. Absorb release. Then what about temperature? Derived quantity. Derived quantity. Temperature is a derived quantity. Is it? Eh? Isn't it base? Base heat. Base heat. Temperature is a derived quantity. 你的5个 base quantity 是什么？你的5个 base quantity length 时间 length mass time current 第5个是什么 temperature 是 base 来的，你的5个 length mass time electric current and temperature. So this is base unit. Base quantity. Okay, now let's understand first before the difference between these two. Now let's say 我拿一个 particle, it can be air, solid, anything. Particle, what are they doing? The particle, if you zoom in, the particle is always moving around. That means they have energy. In the form of motion, they are always doing like this. They never rest. 他们不可以定下来的，永远都是在动的。OK， 所以他们在哪里拿到那个 energy? This is the energy due to motion. They're always moving, so they have certain energy. 我们叫它 internal energy. OK， 那个等下我们再进。我们 try not to give all the terms first. So you have particle with an energy. Now let's say I go to one particle. Let's take a substance. Let's say this one. 我去一个 particle， 我问他 ，OK， 你有多少个 energy？ 我把它写下来 ，E1。我去下一个 particle， OK， 你有多少个 energy？ I write down E2. I go to the next one again. How much energy you have? E3, E4, E5. Every single particle I go and ask. Then I add up everything. After I add up everything, then I divide by how many particles inside here. If there are 100 particles, then I divide by 100. What am I doing here? I'm finding the average. The average energy. Okay, so total energy plus altogether divide by total number of particles. I get average energy. 或者我叫它 average kinetic， 因为 mostly 都是 kinetic 嘛。Kinetic 意思说 energy of movement. When you have movement, you have kinetic energy. Okay, so average kinetic energy is your temperature. 意思说你找到它的 average value， 那个就是它的 temperature， 它的温度。Now， 如果我要 increase 我的 temperature， 单单 increase 一个 particle 的 energy 是不够的，因为如果你要 increase 那个 average， 你一定要每一个都上，对吧？你单单 increase 一个 particle 的 energy， 你可以 increase 它的 temperature 吗？太小了。Okay, but if I want to increase this one, then I will increase every single particle, then only it will push the average up. Okay, so understand that how do I increase the temperature of this substance? I have to give it energy enough so that every single particle can push up the average value. Then only the temperature will rise. Okay, so that is temperature. Understand this. average kinetic energy. If they ask you, then you say this one, average kinetic energy. Now, 你看在空气 oxygen, okay, air is made up of what? Nitrogen, oxygen. Of course, you have carbon dioxide, all that lah, okay? But the two main thing, this one. This one, let's say in this room, what is the temperature of this room? Let's say 16 degrees. One temperature, one average. If I can separate these two, 如果我把这个两个 A 分开，我分开 nitrogen 跟 oxygen. Which one is lighter? This one is lighter. This one is heavier. Lighter atom, they move faster. That means they have higher energy. That means they have higher average kinetic energy. This one heavier, they move slower, they have less energy, they have less average kinetic energy. So 如果我可以把这个空气分开 ，nitrogen, oxygen， 你会拿到不同的 temperature。这个有一个 temperature， 这个有一个 temperature， 这个的 temperature 比较高，这个比较低。可是我把它们掺起来的时候，我拿到只是一个 average， 就是16 degrees Celsius。Okay, so if I separate it, then I get two different temperatures. Why? Because understand that temperature comes from where? Average kinetic energy. Okay, so that's the first one. Now, 我们现在看将它跟 heat 有什么分别 ？Temperature, then what is heat? Heat is 我去每一个 particle, write down the value plus all. I get total. Total energy. This is heat. What is the difference? Temperature, I get average. Heat is the total value. So if I divide by the number of particles, then you get this one. Okay? So the total amount of energy to every single particle you can find in here, that gives the heat. That's the total heat this thing has inside it. Okay, so you see, to give you an idea the difference between these two, let's say 我拿一个 coffee, okay, anything, 80 degrees Celsius. In the morning, you make a hot cup of coffee, and then this one is 80 degrees Celsius. If you compare to the ocean, in the morning, it's cold, it's not as hot as this one, 80 degrees Celsius. This one is hotter than this one, right? Because temperature is higher. We say that this one is hotter than this one, but this one has more heat than this one. You see the difference? This one hotter than this one, but who has more heat? This one has more heat, even though the temperature of this one is a lot less than this one. But the ocean has more heat than this one. Why? 因为 comes to the understanding of temperature is average. 因为你这边只是one cup of coffee, you have less particle than this one. So you have less particle, the average value is higher. Temperature is higher. This is hotter. But heat is every single energy that the particle has. If you compare here and here, how many particles? This one is a lot more than here. So even though this one is lower in temperature, 20, like this, lower temperature, but you go to every single particle, what is the energy? Add. The total is going to be a lot higher than this one. That's why we say the ocean has more heat than the coffee, but the coffee is hotter than the ocean. That is the difference between these two. Okay? Because the total energy. 如果 let's say 我要 increase 这个80 to 81，我要讲 increase. How many particles inside here? I give the energy. Is it easy to push up the average value? It's easier than this one. So you give it a certain energy, E1, to push from 80 to 81, to push the average up. But how about this one? If I want to increase 20 to 21, how much energy I need to give it? E2. Wow, you have to push the average of the ocean to rise by 1. Because temperature is the average kinetic energy. To push the average of the ocean by 1, you have to supply huge amount to every single particle. That's why 他们讲，如果你的 ocean rise 1度，其实是 a disaster because this is a lot of heat energy inside. That's why 人家讲 the ocean temperature rise by 3 degrees. It's very bad already. Why? 3 degrees, can you imagine how much heat you put inside of it? 3 degrees. Other people, they say 3 degrees, I have nothing. But 3 degrees, imagine how many particles here you have to push up. So if you look at the earth, right, which part of the earth stores the most heat energy? Is it the atmosphere? Is it the land? Is it the mountain? Is it the object? Or is it the ocean? Oh, the ocean always stores the most heat, yes. That's why people say, we face energy crisis. How do you get the energy? Where you get it? If you can design something to get the heat from the ocean, then the problem is solved. Okay? So the most heat you found in is in ocean. Okay, so understand what is the difference? Heat and temperature. Okay? Now, temperature, you can, if they ask you, you can answer here, average Ke, or you can say degree of hotness or coldness. Heat is the total internal energy. Okay, take this down. If you forget, we do you can do like heat versus temp. What are the differences? First is the meaning. Total internal energy. This is heat. Total internal energy. Total internal energy. Hot now temperature is average kinetic energy. 你可以讲 total internal energy 或者 total kinetic energy. Okay, internal energy 就是 kinetic energy that the particle has. What is the second one? Temperature, degrees Celsius or Kelvin. Heat, we use Joule. Yes. Okay, this is the difference. This is a base unit. 所以刚刚 Edmund 讲标准 ，okay, this is base, this is derived. It's a derived unit. Okay. Let's say, let me erase this one. Two object, 这个是 20 degrees Celsius, this one is 80 degrees Celsius. I place it touching each other. Is there heat flow from A to B? A. Is there heat flow from A to B? B to A. Who says got heat flow from B to A? 所以讲 heat flow from B to A. Go ahead. Then who says heat flow from A to B? Then what is it? 两个一起 yes, okay, 两个一起. So here, heat flow from A to B, B to A. Which one is greater? A to B or B to A? B to A 啊 ，B to A 是没的，所以我们讲有 net heat flow from B to A. So if net heat flow from B to A, at first, why there's net heat flow? Because there's a temperature difference. Okay, if there's no temperature difference, then heat cannot flow. Now, heat flow from this one to this one, then what happened to B? This one, 80, because heat is coming out from here, right? Go here. So 80 will drop, 20 will rise. And then you put it after some time, they will achieve 20, go up to maybe 40. This one, 80, drop to 40. Okay, they achieve the same temperature. When they achieve the same temperature, the condition, the state of achieving the same temperature, this one we call it thermal equilibrium. Okay, now 在 thermal equilibrium 的时候，还有 heat transfer 吗？没有。当它 reach thermal equilibrium 的时候，还有 heat flow 吗？每个人。哦，有。OK， 当它到一样的 temperature 的时候，是什么 ？reach thermal equilibrium. Is that still heat? Answer is yes. There's still heat flow, but the heat flow is the same. 这里去这里，跟这里去这里 is the same. OK， 你有多少 heat flow 去这边就 same heat flow 回来这边。OK， 它的 rate 是一样的，这个 rate of flow 啦，去这边跟回来是一样的，所以它们两个是一样哦，所以 cancel 掉。所以我们讲 there is no net heat, no net heat flow. Is there heat flow? Yes. Is there net heat flow? There's no net heat flow. Okay, because this one is the same. Okay, now at thermal equilibrium, what you need to know at thermal equilibrium, they have the same temperature and there's no net heat flow. Now, reaching thermal equilibrium, who is cooling and who is heating? This one, object B is, 因为这个80跌嘛，所以我们这个是 cooling, and this one is heating. Who is the one that is cooling? The one that removal of heat. This one is what? Heating is the absorption of heat. Cooling 我可以讲是它 absorb cold 吗？ There's no such thing. There's no such thing as cold. Cooling is the release of heat, not the absorption of cold. Okay, so there is no such thing as cold. Cold is basically absence of heat. Okay, so 当你解释的时候，你只可以讲 heat transfer， 你不可以讲 cold transfer. Okay, so two objects again. Let's see what we did here. Two objects. There's net heat flow. Net heat flow 永远是 flow 从什么去什么？大的 temperature 去小的 temperature。然后当它从大去小的时候，从 heat 那个 heat 从 B 走出来 ，heat 从 B 走出来，所以这个是 removal of heat. That's why B is cooling. A, absorption of heat. So this is heating. Okay, so the temperature, one drop, one rise, and then they achieve equilibrium. Same thing here. If I see a cup of 50-degree water, and I put ice cube here, 0 degree. Two objects here, again in contact. They are touching. We call it thermal contact. Thermal contact, thermal contact. 两个 object, liquid and ice. Where is the net heat flow? Hotter to cooler. So from water into the ice. Who is removing heat? Whose heat is being removed? The water. So water is the one that cools. This one is cool. Who is absorbing the heat? The ice is absorbing. So this is heating. We call it heating. So heating doesn't mean you have to 烧它，不一定是你烧它就是 heating. As long as it is rising in temperature, then it is heating. Okay, so the exchange in temperature, cooling, heating. What is the effect you see when this happens? What is the effect you see? And the effect is temperature drops. What is the effect you see here? Temperature rise, and then what is the effect? Melt. Yeah. Okay, ice melt due to absorption of heat from where? Ice melt due to absorption of heat from water. Okay, so this is the interaction between two objects. So you have to make it very clear. It is always the interaction between two agents, two objects. Why mean your interaction, Emma? Yes, of course. The surrounding air here, this air is also going to give heat or take heat, depending on what is the temperature of the air around it. If the temperature of the air around it is higher, then it will give heat into these two things. If the temperature of the air around is lower, then it will pull heat out because, again, hotter, rate of heat move to cooler. Okay, huh? So that's why sometimes we take, okay, insulator. We put an insulator here. So there is no heat can escape and go into it. So if you put insulator around it, then you're only studying the heat transfer between these two objects. 没有外面的影响. Okay, so if you understand this, then you understand what is really cooling. What is the meaning of cooling? Let's say 如果我要 cool 这个东西，我有一个 object， OK， 10度。如果我要 cool 这个东西，我要做什么？我想 cool 它，加冰，加冰，这是 solid。If you want to cool it， 你放在冰箱，你放在冰箱。Then what is the difference if you put it in the ice box and outside here? That is the temperature of the surrounding air. Temperature of the surrounding air. So 如果你要 cool 它，你一定要 make sure 你的周围的 temperature 是低过10，你才可以 cool 它。如果你的周围的 air 是高过10，这样你就 heat 它。为什么？因为 heat flow higher temperature to lower temperature. Here to here. So if your surrounding air is higher than 10, then heat will flow into you. If this one is lower, then heat will flow out of it. That means the air is pulling it away. So when the air is pulled the heat away, then what happens to this one? This is cool. This is cool, then the air, what happened? The air is heated. It is always two things that is happening. When one is cool, another one is heated. It's never just one thing. Okay? The ice box, you put your food in the ice box cool the food. What happened to the ice box? The ice box get heated. 不是因为你的 ice box 什么 special 可以一直 cool 它，是因为你的 ice box 从 heat 在 food 里面拿出来，然后从它的后面放去外面。That is what it's doing. Because the ice box cool your food, they also get heated. They have to remove the heat, otherwise they cannot keep cooling. How do they remove outside? Then you have to make sure the outside is cooler than this one to pull the heat out. You see it? Right? 这个 cooler than this one, pull the heat out. 外面 cooler than this one to pull the heat out. Okay, so it's the same for aircon also. How does it cool the room? The aircon. How does it cool the room? Takes the heat from the room, throw it outside. So the air inside here is cool. Then what happens outside? You stand behind the radiator of the aircon, the fan is very hot. The heat is all from the air inside here. Okay? Right, so understand the heating and cooling. What does that mean? Now, 这里我 cool 它从10 temperature drop. Okay, 98 heat 0. 我可以再继续 cool 它 down. What is the lowest temperature I can cool it down to? 最低的 temperature
negative 273.
Negative 273. What do you call this temperature? Is this the lowest? What do you call it? The name? Absolute. Yeah, I mean absolute zero. Okay, absolute zero is the coolest temperature in the universe. Minus 273 degrees Celsius. Okay, how do you cool something down to this temperature? 为什么这个会是 lowest 呢？你要 cool 这个，你要东西是低过它 ，to 拉它下来。如果你要 cool negative 273，你要讲 cool 这个，你要有一个东西是再低过 negative 273，再把它拉下去。问题是我们没有那个东西。liquid hydrogen, liquid nitrogen is it? You're trying to see. You're trying to see. Yes, liquid nitrogen is very cool.
还有 solid oxygen.
Okay, yes. Or then recently they have another one. Liquid what? Liquid helium. Liquid helium can reach much cooler than liquid nitrogen. 他们用 liquid helium try to cool liquid helium down to very close to negative 273, but not exactly negative 273. Why not exactly? Again, same reason, because there's nothing that is cooler than this can pull it down to exactly 273. That's why they can only cool it down to this much, nearest minus 273. All right, so the coolest temperature is not in somewhere in the universe. The coolest temperature is in the lab. What they created here is in the lab.
所以 temperature 是看有没有 如果没
Yes.
有不知道negative 273。
Temperature is can average kinetic energy. Yes, average heat energy. Okay, average heat energy. Now, 这个 idea temperature 是看 average heat energy 对吗？这样如果是完全是0 Kelvin， 这样代表什么？没有 temperature， 没有完全没有 heat energy。因为 temperature 是什么 average kinetic energy 对吗 ？average heat energy。所以如果我讲0 temperature， 0 Kelvin， 也就是这个温度 absolute zero， 你是完全没有 energy， 完全没有 energy， particle 在做什么 ？particle 完全停下来，就是固定着 ，OK， 固定着。然后他们讲这个是没有可能发生的。Based on our understanding, particle they cannot be at stationary. That's why it's one of the reasons why you cannot achieve absolute zero. Okay, so what happens when you cool the liquid down to absolute zero? You start to see some strange thing. Like, 如果你拿一个杯，你倒 liquid helium at this temperature, what do you see? 你拿它这样子，那个 liquid helium 会自动这样子爬上来，然后自己 spill. Yes, it can climb itself, the wall of the glass. It can climb the wall of the glass and then spill itself. This has been done in the lab, in the experiment. They actually see the cup few minutes later, and then it's dripping down. And then they see the mercury level inside is reducing. The level of mercury, level of helium is reducing. After some time, it's no more. Okay, so that means this is your cup. That is the helium. Then it can climb itself. It can spill like this. Climb itself, spill like this. Until here, no more. Because why like this 呢？因为它讲在降低的 temperature， 你完全是没有 friction， 完全没有 friction， 也就是讲 water can do whatever it likes, climb here, climb there. If you put your hand inside the water, you couldn't feel anything. Just like you put your hand through air like this. If you put your hand in the water now, you can feel anything. You can feel something. That is because of the friction. The water is pushing you, you push it, you push it. That is because of the friction and surface tension, all that. But at this temperature, you put your hand like this, you cannot feel anything. Okay, so at this temperature, it's completely no friction. Okay, so that's why they say liquid, when object at very low temperature, they behave very strange. Many things they can behave. No resistance, no friction, all that. Okay, let's come back. Now, so we talk about, what is it? Thermal equilibrium. Why is thermal equilibrium important? 你去看医生，医生要量你的体温，他讲量。Which part of your body is the most accurate representation of your temperature? G-bar. Which part? The tongue. Okay, the tongue and your armpit is the most accurate measurement of your temperature. So the doctor take the thermometer, they put it under your tongue. They wait for what? 1-2 seconds. Why? Thermal equilibrium. They have to wait for the thermometer to reach thermal equilibrium so that your body temperature matches with this one. Then only they have to take out. Otherwise, they will be not accurate. That is the importance of thermal equilibrium. If you, before you see a doctor, you go and drink 1 hot water. You should have doctor put inside. Here, they read 42 degrees Celsius. Something is wrong with you. But then, what's the reason? Because you drank the hot water, so your temperature higher than usual, than what is supposed to be temperature higher. So when you put here, they achieve thermal equilibrium, but at higher temperature. That means this is a false reading. This is a false reading. Okay, so that is thermal equilibrium. Now, okay, now let's say I want to measure the temperature of the water. Here I put the thermometer. The thermometer inside is filled with mercury. Mercury is poisonous, not in the liquid state, it's in the gaseous state. That means if you 如果你不小心打烂这个 mercury 在你的手，它是不危险的。可是如果它变成 gas 的时候，你去吸这样子，they can kill you in 1 or 2 days, not even 1-2 days, maybe a few hours. This is very poisonous. So if you do experiment, be careful. The mercury thermometer. Okay, so it is the vapor, the gas state that is very poisonous. Okay, so here I put mercury inside. I want to take the temperature of this thing. What should I do here? I have to wait. When I put in, right, the mercury, what will the mercury do? The temperature of the water, T, they will transfer, right? 当你放进去的时候，已经有 interaction between 2个 object 嘛，所以这个100 the thermometer, okay, maybe 37, any temperature. So this one heat will transfer to here. When heat transfer to here, the mercury inside get the energy. What does it do? It will expand. When mercury expand, there's no way to go because the side is glass, the other side is glass. There's just one way to go, which is rise up. So this transfer of temperature is being converted to the expansion in the mercury. Okay, the more heat go here, the more expansion like this. The more heat go, the more expansion. So you put inside, it keeps rising until you have hit thermal equilibrium. Now, thermometer, 它这里的 area 是很小的。为什么要很小？因为它要 make sure 当这个 heat 过来的时候，这个100不会跌。OK， 就只要你拿两个 object A、B， 这个100，这个20，当 heat 过去的时候，因为这个 object 是很大个，它一直拿 heat， 所以它会弄到这个100跌去40，这个20上去40，所以当它 achieve thermal equilibrium 的时候，它的 temperature 都不一样了。OK， 当它 achieve thermal equilibrium， 你的 reading 就是 incorrect reading because it was supposed to be 100 at first. That's why the thermometer they make sure this one very small so that it doesn't change the original temperature of the water. Okay, so heat flow, mercury rise. So we say that the flow of heat has been converted to the expansion of mercury. And then mercury rise until equilibrium, then you take away. You stop taking the reading. Take this out, you take the reading. Okay? Now, thermometer 它会问你这样的问题呢，在我们的 syllabus. At first, they will ask you, 为什么我们用 mercury? Why do we use mercury in the thermometer? 记得吗 ？Heat flow 进来 ，mercury 会 expand。为什么我不要用 alcohol 或者其他的 liquid？ 因为 mercury expand is very linear. Okay, what does it mean? Expand linear means for every 1 degree rise, the mercury is going to expand by same amount. 1 degree rise 1 mm. 1 degree rise, this one will also maintain 1 mm. 1 degree rise, this one maintain 1 mm. It will never be suddenly 1 degree rise, this one go 3 mm. In this case, it's non-linear. Okay, you already know. Same changes, this must be the same change. So this has to be 1. Okay, so mercury behave like this. We call it mercury expand linearly. That's why it can be chosen as the thermometer, inside the thermometer. Okay, now mercury 只是 linear between 一个 range 罢了。什么 range? 0 to 100 degrees Celsius. 刚刚好，这个就是我们要的 range。也就是说，你讲200、300、400，它就开始不会是 linear 的，只是在这个 range 是 linear。Okay. Okay, now the second one. So the first thing is linear reading. Why we pick this one? Because of this. Okay, then we look at again what is sensitivity of thermometer. Sensitivity of the thermometer. So let's say 第一个 thermometer 我给它 very small diameter. Okay, let's just say this is 50 cm3. The second thermometer, I make it much bigger diameter. Like this. 50 cm3. If I heat these two, and then temperature rise by, okay, 20 degrees Celsius increase. How much is this going to expand compared to this one? Because this one, the diameter is smaller, so the 50, same volume, this one is gonna take more length because it's smaller one. So to have 50 cm fitted inside here, the length has to be longer compared to same volume to have 50 cm cube fit in here. Okay, 同样的 rise in temperature 20，这个 rise this much, 这个 rise this much. So which one is better? Of course, this one is better. Why that one is better? Because I can put more scale on it. I can put smaller scales, but this one I cannot put small scale. This one is just 1, 2, 3, 4. This one 1, 1.2, 1.4. Smaller and smaller unit I can put. 这个我们叫 sensitivity. Okay, so sensitivity, this one has more than this one. Okay. So 1, 2. Another thing is the range. Range, very straightforward. What is the minimum and maximum that it can measure? Okay, so mercury can measure down to negative 70, 80 something. So it's way below zero. It is suitable. And this one, we can measure up to 200, 300 before it boils. Before it boils. So it is just right within this range, the range of mercury. If you take another type of thermometer, the alcohol one, alcohol, instead of mercury, they use alcohol inside. Alcohol has a much lower freezing point, negative about 300 plus minus. That means it can measure very, very low temperature. Okay? Before freezing. 这个是它的 freezing point 啦。所以如果你 reach 这个 temperature, 它就变 solid. Okay? So way below here, the freezing point, so you can measure very, very low temperature. But do we use alcohol here? Usually they use it in the cold climate. Cold climate, okay? Because that is where everything is very cold. But in normal lab, your school lab, they more to mercury thermometer. So 不管它是 alcohol, mercury, 它们两个叫什么 liquid in glass. Okay? Liquid in glass thermometer. You have many, many types lah. There are really, really many, many types lah. But the one of the type is liquid in glass. So liquid in the glass thermometer. Okay, mercury and alcohol. Okay, now next one, a bit more, then I'll give you exercises. Okay, calibration of thermometer. What is the meaning of calibration? Means you put the scale inside. Okay, 就这样你拿 one thermometer. At first, there's no scale. So you are the one that put the scale in. The process is calibration. Okay, putting the scale in. How do I put the scale in the thermometer? Now, it will ask you, what is the upper limit? And what is the lower limit? That is the 100 degrees Celsius and the 0 degree Celsius. So how do you get the 100 degrees Celsius? Here we will take the boiling water. Okay, so what you will do is you will take the thermometer here. You are getting the temperature of what? The steam. Steam, the hot gas. Okay, just above the liquid, but not inside the liquid. Okay, so we are taking the temperature of the steam. Wait until it rises. Thermal equilibrium, a few seconds. Then we take that point. So this is the upper point, 100 degrees Celsius. boiling steam. Then take another. Now we put ice cubes. This has to be distilled water. No salt content, no other things added into it. Pure water, distilled water, because that is going to change the freezing point. Okay, put the thermometer in. Again, wait. Achieve thermal equilibrium. This one drops. Stay. Then we take the reading. 0. So our thermometer should have 2 markings. The upper limit marking, the lower limit marking. The rest is not yet got the scale. It's still nothing here, just 2 marking. Now, 当我有了这个2个 marking， 因为我知道 mercury 是 linear， 也就是讲每一个 degree 它的 expand 是一样的。因为我知道它的这个 property， 所以我可以直接把这个 length 除100，除100，所以我就有100个 scale。1 degree, 2 degree, 3 degree. There's no scale that is wider than the other like this. It's all equal spacing. Why do I do that? Can I do that? Yes, because mercury is linear. Okay, so depending on what is the length here. So how the question will ask you, they give you here 5 cm. Here 30 cm. 5 cm is measured from here. 这个我们叫什么？这个我们叫 bulk. The bulk that is holding the mercury. Okay, this is the one that achieve the thermal equilibrium. And then inside, you got. Okay, if I zoom out this one, this is the thermometer, and then inside is the column that fills the mercury. 这里我们叫 bowl。OK， 旁边这里是 glass 来的，这里是 glass。The mercury is in the bowl. So sometimes you see ball thickness. Okay, smaller ball thickness is like this one. Larger ball thickness is like this one. So how do you increase the sensitivity? Decrease the ball thickness, so that more mercury can increase like this. Okay, now 当你有你的 upper lower limit, then we take the length 5 cm, 30 cm. Okay, then what is the length over here? This length here, 30 minus 5. Okay, we got 25 cm. So here between 0 and 100 is 25 cm. Then you find 25 cm divided by 100, 0.25 cm. That means 1 degree is 0.25 cm. Okay. If you want to find 1 degree, then you divide by the temperature. If you want to find 1 cm is how much, then you flip this. Okay, divide by the cm. So 1 degree is 0.25. Now, after you got this one, 1 degree is 0.25. Then they will ask you, what is the temperature? What is the length? If this one gives you 60 degrees. Okay, what is the length if this one gives you 60 degrees? So you take 0.25 times into 60. Okay, so you first get the ratio, then times. Now, is this your answer? 15 cm? 你看你的 length 是从哪里哦？25 cm 是从0去100，所以如果你放60，你找到的15 cm is over here。Over here, this is your 15. That means you have to plus this. 因为你这个是25 cm 这边嘛，这边除100 ，OK， 所以1度是0.25 cm。你的60度是 measure from 这个0啊，所以你要小心1度是0.25，可是是 measure from 0。所以我放60度的时候，我找到的15 cm 是 measure from 这里去到这里。Then if they ask what is the length, you have to take 15 plus 1. Length is 15 plus 5. 20 cm. From where? From the bulb. From the bulb.